Now we're going to move on to our question and answer session of the webinar. I'm going to go ahead and ask our first question. Could the USGS discuss how they are reaching out to local and state emergency responders to ensure their data is useful for emergency response decision makers, and how that data is in a format useful for analysis? How are they, the USGS, bridging the gap between scientists and decision makers?
Okay. Most of the tide gauges that we're operating in the Hampton Road region are actually being partially funded by those state and local emergency management agencies. So we work with them quite closely in terms of obviously locating the tide gauges in locations that they need them. All of the data is available real time, so they have access to the data as it's coming in, so that they can make decisions during storm events. We also, during a major storm event, we will go out and locate what we call rapid deployment gauges, which are additional gauges that we can deploy kind of on a moment's notice to collect additional data that's also available real time. And that way, if we were to have a tide gauge that was overtopped, we would have additional information that would support, that would help support what the local and state emergency responders are doing. We work very closely with those groups to make sure that the data that we're collecting meets their needs.
Great. And I believe Virginia wanted to make a quick correction to her something she said in her presentation.
Oh, yeah, I was just remembering that I've said redfish, and I had a picture of a red snapper when I was talking about fishery management next to the instrument that we use to measure marsh accretion and vertical accretion of sediments in marshes. Anyway, just wanted to correct that. We managed the redfish, speckled trout, and red snapper all about the same time, trying to ensure the sustainability of those species. But also, let me add, during Hurricane Katrina, I remember that just what Mark was talking about, that real-time data used by emergency managers. I remember people being glued to the internet and trying to watch the storm surge as it was coming up in the Gulf Coast during Katrina, and how important it was to, eventually a lot of the instruments were knocked out, they were overtopped, but it really was an indicator of what was coming.
Thank you, Virginia. So now our next question, what do you see as appropriate roles for states and the federal government in developing and maintaining data collection networks? Can you suggest a philosophy that would help define these roles?
I mean, I can start from the USGS perspective. There's certainly a balance there between state and federal, the state and federal government. Again, a lot of the network that we run in West Virginia and Virginia is actually funded by different state agencies that's somewhat tailored to their needs for specific reasons. It might be where they're trying to collect data for low flows for water supply. It could be where they're interested in collecting data for peak flows to help Department of Transportation's design bridges and culverts. But there's also a need for a federal backbone of gauges as well. And those are gauges that are typically funded by USGS. A lot of times the Weather Service has forecast points at those same gauges for predicting floods, et cetera. So really there's a balance between states, the federal government, and even localities. So localities fund a lot of gauges as well, again, that might specifically meet their needs. Most of our water quality sites also have gauges as well, because gauges end up being critical for looking at trends and loads at sites. So it's really a diverse network, and I think the diversity kind of helps with the overall stability of the networks that at least we operate in Virginia and West Virginia.
On that last question, this is Virginia with USGS, the philosophy that would help define roles. I talked about free and open data, but the interoperability of that data and collaboration, I think that with technology now we're moving towards a greater ability for people to work, state, local, federal government, NGOs together on developing data sets that can be used together in models that require inputs that truly reflect the complexity of environments from the biota to the physical realm.
Thank you. We're going to move on to our next question unless one of our other speakers would like to comment on this one.
I was just going to add about seismic networks on this. I mean, I was talking about a global network and a local or a U.S. network, but there are a number of state networks, both Northern and Southern California have data, and a lot of the funding for those actually comes from the state, and they work closely not only with the state governments and the federal governments, but also with agencies like the gas company and power systems that are going to be dealing with the aftermath of an earthquake. So I think in those cases there is a role for the states to be paying for the collection of the data, while the global network, that's more of I think a federal responsibility. And again, the free and open network made available to people in a format that they can use is, I think, key.
Thank you, Katrin. Tim, do you want to chime in on this, or would you all like to move on to the next question?
I think the one thing I would say is just I think the role for state and federal government is long-term observations, long-term reliable observations. That's a key area. We don't want to rely upon citizen scientists or industry to really be collecting that long-term data.
Thank you. We're going to go ahead and move on to the next question. It was mentioned that the satellite imagery data are free and open-based, and how does one go about researching the availability of such data and accessing it locally?
I would suggest that you go to, this is Virginia Burkett, go to the USGS website, and you can Google EROS, E-R-O-S, and get access to the Landsat archive. But we also have this global visualization viewer that you can get to that delivers different types of data, not just Landsat. But go to the USGS website and just enter Landsat, and you'll have access to the entire Landsat archive and some of the new European data that we're now delivering through EROS for the Sentinel satellite.
Next question. In what ways do earth science data contribute to our economy? Kind of a broad question, but we'll see what you have to say.
This is Tim. I can start, but if you remember the program that I talked about, the Air Now program, that's real-time data that are collected and made available to anyone that wants it. There are a wide number of app developers, small businesses that have created apps that they charge for that use this data and repurpose this data and display it in interesting ways. So that's one very small example, but you know, the other example that I mentioned is in genomic research. Having that data available allowed them to do better genome research.
And this is Mark Bennett with USGS. I mean, a couple of examples. You know, I talked a lot about data that we're collecting to help offset or understand better what might be occurring with sea level rise. There's at risk are huge amounts of resources along the coast. We can certainly, you know, that data can be utilized to offset losses that might be occurring during large storms. We also collect a lot of data with regard to water use and availability. And water is a huge issue as we move forward with regard to local economy. You know, industry, et cetera, needs water in order to grow. And increasingly, what we're seeing across the country really is that we are starting to run into acute water shortages in certain areas that are certainly restricting their economy.
Yeah, this is Katrin. The earthquake data, as many people I think have heard, there's an increase in seismicity in a number of states that is related to the reinjection of fluids during fracking operations and that sort of thing. So I think there's a lot more research going on into what's actually causing this and how this relates to the development of resources in the U.S. And there's, I think there's a lot of things that aren't understood, but that we do need to understand in looking at how we can safely retrieve those resources.
Thanks, everyone. So I'm going to move on to the next question. One example of effective applied research with local partners is developing common data standards, for example, field data collection and compilation. Can speakers comment on how they or their agencies integrate with other agencies' results for decision-making needs in major incidents?
This is Mark. One thing I can comment on, for instance, all the tide gauges that we've installed along the coast, we do that in coordination with NOAA to make sure that we meet NOAA standards. NOAA actually pulls in all of the data that we collect into their system as well and converts it into a kind of a common datum so that they can utilize it as well. So we work very closely with NOAA and the Weather Service on both coastal flooding and interior flooding.
Yeah, this is Katrin. In terms of the seismic data, IRIS was instrumental in helping establish a common data format for seismological data throughout the world. And if you need to, or if you want to archive your data at our facility, it has to be in that standard format. And what this allows us to do is to develop a large suite of tools to convert that data format into ones that different agencies use. The USGS in particular will issue, after a big earthquake, they'll issue like a one-page document that talks about the geology and the potential for other earthquakes in the area. We also get data that will actually be sent to a laptop in an office for the gas company, for instance, so they can actually see where the most damage was and that sort of thing.
Thank you. We're going to move on to the next question, which I'm going to combine. So what do you see as frontiers in earth science data collection and dissemination? And I'm going to combine that with a question I received from the audience. What major advances or shifts in data collection do you see happening over the next 5 to 20 years? And how should decision makers foresee these changes and adapt to them?
This is Tim Dye at Sonoma Technology. I think the big thing I see is this emergence of, we can call it citizen science, others are calling it Internet of Things, but the democratization of monitoring. Anyone can begin to go out and start monitoring. We saw this, about a decade ago with backyard weather stations, and there are thousands of backyard weather stations, and that data is now being collected by the National Weather Service and utilized. But we're going to see the same thing with air quality with other data sets as well. And I think there are some real fundamental challenges of how do you use noisy data or uncertain data, and how do you merge kind of high quality, mid quality, and perhaps even low quality data sets to get a better picture or a better situational awareness of what's going on. I think this is a huge, huge area of research and opportunities over the next probably 5 to 10 years, and there are lots of different organizations that are looking at it. And I think it's really exciting.
This is Virginia Burkett chiming in on what Tim said. Citizen science, we've learned through the years of the breeding bird survey that if it weren't for volunteers that we wouldn't be able to really assess the status of many species. in North America, and the timing and arrival is affected by the changing temperature, that sort of thing. The other aspect of that is the National Phenology Network, starting out at universities in collaboration now with USGS and many, many others. The NPN, National Phenology Network, is how the U.S. is able to track the emergence of the leafing out of plants and different other variables that help us track how climate change and other things are influencing the phenology of plants. I think one of the most exciting things to me is this concept of data cubes. And when you've got this massive, particularly in terms of the satellite archive, the ability for a user, let's say a person that's managing sage grouse in the West, to be able to go in and look and slice through this entire Landsat archive, as one example, since 1972, and look at when changes in the landscape actually happened, and then you can look at how restoration that they're planning and management of habitat is effective into the future. And to do that, you not only have to have the data, but you have to have it accessible. So this accessibility, not just free and open, but easily accessible by users, I think is a frontier that we're really stepping out in quickly. And that's not just in the United States, but Geoscience Australia has really pioneered some of this. And in Europe, the way most of the phenology data globally is hundreds of years old. They've had that sort of thing in Europe. So it's emerging in the United States, but also prominent in other countries as well.
And I think with regard to water resources data, one of the things we've seen in the last few years is the collection of continuous water quality data. I think the next big thing is going to be collection of water resources data through remote techniques. And both of these give us challenges because we end up collecting such huge volumes of data that then we have to quality assure, quality control that data, and then also figure out how to store that data. And I think that we're going to see more and more of this data being collected remotely in the next couple of decades.
This is Katrin. Just in terms of frontiers in earth science data, there are a number of sort of citizen networks now for earthquake recordings, because a lot of the smartphones these days have basically a device that measures acceleration. So, but the quality of that data is probably not good enough to, for long-term data collection. But there are some immediate uses of it, perhaps for early warning and that sort of thing. But one other thing I'd like to point out is that when we talk about these seismic networks, they're primarily on land, and of course the Earth is covered 2/3 by the ocean. So I think an area where we will see an increase in data collection, hopefully, is actually having permanent seismic stations in the oceans. And the technology is changing rapidly. The big issues are how do you actually install the sensor, and then how do you get the data back, since the telemetry systems don't work very well in the water.
Thank you, everyone. We're going to go for one last question, and this one's going to be for the students out there. How can students plan for the future of earth science data? This can be very much an arm-wavy philosophical answer, but I thought I'd throw that in there.
This is Katrin again. I would say one thing, they definitely have to have extremely good computer skills and realize that all of this data is going to be accessed via computers, and so you know, when I was a student, we didn't do so much computer programming and that kind of thing, but I think that's going to be a very key element and a key skill for them.
Yeah, this is Virginia. I think any student in any field of earth science should, you know, I would look for incoming professionals to have some exposure to GIS training, statistics, remote sensing, and also I want to emphasize communication. A lot of times we hire folks that don't write very well, don't communicate well, and so I think preparing yourself for the workplace and taking some courses in that regard is an asset too.
I think this is Tim Nye at Sonoma Technology. I think the one thing I would say is reach out. There are many opportunities for internships, for co-ops with many of the federal agencies, with state agencies, and get experience, early on in your educational training.
All right. Thank you all so much. That's all of our questions for today's webinar. Please join us for our next Critical Issues webinar, Desalination as a Source of Fresh Water, which will take place in September of this year. If you have any questions that were not addressed today, you can email us at cipinfo@americangeosciences.org, and we'll make sure to send your questions along to the speakers. We will be posting today's recorded webinar on our Critical Issues webinar page soon. You can visit the website to view this webinar as well as previous ones, and please follow us on Twitter as well to see the latest Critical Issues content and webinar announcements. Thank you very much, Virginia, Katrin, Tim, and Mark for speaking today, and to the Advances in Earth Sciences Coalition for organizing the original briefing and briefing series. This concludes our webinar for today. Thank you so much for joining us, and we look forward to seeing you at our next webinar.